Welcome students to our lesson for Monday, September 14th. Today we'll be going over lesson number 8, multiplicative comparisons, patterns with multiples. Our learning targets for the day: I can identify patterns with multiples and reflect on the implications of these patterns as they relate to factors. I can relate the patterns I see to the multiplication facts table. Our essential questions are remaining the same as they were last week for Unit 2. How can patterns within the number system help solve problems? And how are numbers related to each other? Our problem of the day: there are 3 green M&Ms in the bag. There are 4 times as many red in the bag. How many are red? So what we're going to try to figure out is what type of comparison is being made here, what's the equation, and we're going to solve using a visual model. I want you to solve this one using your math notebook. So inside of your math notebook, I want you to be able to solve this one. And let's take a look again. There are 3 green M&Ms in the bag. There are 4 times as many red in the bag. How many are red? Type of comparison is either going to be a multiplicative comparison or additive comparison. So we talked a lot about that last week: multiplicative comparison or additive comparison. So we're going to use our cubes strategy to help us solve this particular problem. There are 3 green M&Ms in the bag. There are 4 times as many red in the bag. How many are red? So we're going to circle all of our key numbers. 3 green, 4 times as many. Remember that key word or key phrase, times as many. And our question: how many are red? Okay, so times as many should be a clue for you as far as whether it's an additive comparison or a multiplicative comparison. So we're going to pause just for a minute. I want you to, in your math notebook, go ahead and answer the questions of what type of comparison, what's the equation, and also solve it using a visual model. So you've had a few minutes to to look it over. So we are going to go ahead and go to our next slide for our answer key. So again, there are 3 green M&Ms in the bag. There are 4 times as many red in the bag. How many are red? So if you answered multiplicative comparison, you would be correct. And the clue is times as many. The clue here is going to be times as many. Our equation: 3 green times 4. 3 times 4. And our answer there is going to be 12. A visual model that you could have used was 4 different groups of 3. 4 different groups of 3. So you have 3 here, 3 here, 3 here, and 3 here. And when you add these all up, you got 3 plus 3 is 6, plus another 3 is 9, plus another 3 is 12. So on our next slide here, we've got the title of 2 truths and a lie. 2 truths and a lie. So one of these statements is going to be false and the other 2 are going to be true. So one of these statements is going to be false and the other 2 are going to be true. Let's go ahead and read them. Number 1 says, not all even numbers are composite. Not all even numbers are composite. And you have to think back to our discussions and our practice on composite. So if you need to go back through your notebook to check the definitions that you wrote in there or some of the practice problems, I want you to go ahead and do that. Number 2, all numbers have an even number of factor pairs. Again, we've practiced with factor pairs. Same thing, if you need to go back into your notebook to examine our work with factor pairs, I want you to do that. Number 3, the number 1 is neither prime or composite. So 2 of these are going to be true. 1 of them is not true. We're going to pause for a minute. I want you to examine those and try to figure out which one is going to be not true. Okay? You've had a few minutes to look it over. Now, number 1, not all even numbers are composite. That's going to be a true statement. That is true. Number 3, the number 1 is neither prime nor composite. That is also true. Number 2 is going to be the false one. Number 2 is the false one. All numbers have an even number of factor pairs. So that number is true because we can prove it. If we look at the number 12, the factor pairs for 12 are 1 times 12, 2 times 6, and 3 times 4. So that means that the number 12 has 3 factor pairs. It has 3 different factor pairs, and that is an even number. So that makes this particular statement false. So now it's going to be your turn to write 2 truths and a lie about factors, multiples, prime, and or composite numbers. Everything that we've been studying for the last few days. You're going to write 2 truths and 1 statement that is not true about factors, multiples, primes, and or composite numbers. So any statement that you can think of, and I don't mind if you go back to your notebook to check some of your notes, and we're going to do this on the very next slide. 2 truths and a lie. Again, you're writing 2 truths and 1 lie about factors, multiples, prime, and or composite numbers. So you've had a few minutes to complete your 2 truths and a lie. So make sure that you do complete it, because when you turn this in to your teacher, it needs to have been done. What does it mean to skip count? Write your answers inside of the chat box. So what does it mean to you to skip count? I want you to type your answers inside of the chat box. We're going to pause for a couple of minutes to allow you to do that. Skip counting allows you to find multiples of certain numbers. Now today, what we're going to be doing is exploring patterns as you skip count on a number line. Patterns with multiples. On the next slide, you're going to start exploring a number line activity, and we're going to do it independently. And for the next 5 to 10 minutes, depending on what your teacher assigned it as, you're going to be completing the number line. On our number line, students will be color coding the actual number line using the colors right here in our answer key. So you'll be color coding the number line using the colors in our answer key. Sorry, in our key. So all multiples of 2 over here will be color coded with the reddish brown color right here. All multiples of 3 over on the number line will be color coded with the red, and so forth with the rest of the multiple numbers. So the way that this works is you will need to click on one of the circles first. So we'll try the first one with multiples of 2s. So we'll click on, we know that 2 is a multiple of 2, and we'll click on the 2, and then we have to go up here to the fill color. You have to go up here to the fill color. Now we're going to find that color. We knew that it was a reddish dark brown color. So we'll pick this one. And we'll go on over. And we're clicking on it. And we'll go to the 4. Click on that. So we got the 2 done. And now we go back up to the fill color. Over here. So we have to click on it first. And then you go back up to the fill color, and we do that color again. Okay, so that's how you do all the multiples of 2. You figure out which ones are the multiples of 2, and then you need to click on the actual number line first. You click on that, and then the fill color will fill in. So you go on up and pick the color. Okay. So if you need help with the instructions on how to do this, all you need to do is click on the help button right here. And there's video instruction about how to complete it if you need another reminder. So our next slide is actually an answer key. So after you've worked on the previous slide, you go to the next slide, there is an answer key for filling in the multiples of each number so that you can check your work. So our next slide is an exercise for you to work on based off of the previous slide, where you filled in the multiples of each number. Patterns with multiple reflections. So what I want for you to do is to analyze your number line, the one that you completed on the previous slide, and think about and write down, what did you notice, what did you wonder about it, and also I want you to complete the other side. Number 1 says some numbers have only one dot above them or nothing at all. List those numbers below. What do you know about those numbers? Number 2, some numbers have very similar factors. List the factors for 4 and for 8. What is similar and different? Is this true for all numbers as they double? Prove or disprove your thinking with a short statement. Number 3, different numbers had various numbers of factors and multiples. Is there an organized way to determine how many factors a number has? So you're going to answer these based off of what your answers were for your number line on the previous slides. So we'll pause for a few minutes and give you an opportunity to do that. So you're going to be filling in on this slide. So after you've worked on the previous slide, our next slide provides some answers for the questions on the right side. So our next slide provides some answers to the questions on the right side. For number 1, 2, and 3, you can kind of compare your answers to these. Over here on the left, what do you notice? What do you wonder? Now, these are going to be your own personal opinions about what you notice and what you wonder. So your answers may be different than another person's answers. On our next slide, what we're going to do, we're going to take a really good look at it. And I want you to think about, and we're going to discuss, where do you see the same and similar patterns here? Where do you see similar or the same patterns here throughout this chart? So we're going to pause for a few minutes, and I want you to look at it really closely and think about your answer. But one of the things that you should be noticing is that all the numbers inside of here that are being multiplied, they're the factors. All the numbers that are being multiplied are the factors. And this 2 times 3 is represented right here, and it has a product or answer of 6. And the product is actually a multiple of that number. The product is actually still a multiple of the numbers. And the numbers being multiplied inside are multiples, are factors. So on our next slide, we're introducing the T-chart for you to be able to find the factors of a number. So right here, we've got the factors of 36 in this particular T-chart. So when we find the factors of a particular number, so again, right here, we're finding the factors of 36. What we're actually doing is we're finding the multiplication facts that result in the product of that number. So when we actually find the factors of a number, we're trying to find all of the multiplication facts that result in the product of that particular number. And you see all of these multiplication facts right here, they result in the product of 36. And on the last one, you'll see that there's a 6 times 6 for the multiplication facts. Now, even though 6 is listed twice, we only need to list it one time. We only need it listed one time when we list all the factors of 36. So our next slide contains our independent work for the day. So our independent work is on this slide, and I want you to identify all the factors of 12 and write them down here. All of the factors of 42 and put them in here. All the factors of 54 and put right here. And this is very similar to our previous slide. Very similar to our previous slide where we found the factors of 36. We just basically found all the multiplication facts for that number. And you're doing the same thing for each of these for your independent work. And lastly, we had our live lesson, of course, at 1:30. And if you did not make the live lesson, you reviewed the lesson online and you watched the video. Our first task is to finish up the T-chart in the previous slide. And if you have not finished the number line in this slide, you're going to also finish that. Also, our other task is going to be working on Khan Academy. Your teacher has assigned you recognizing prime and composite numbers inside of Khan Academy. So you're going to need to go to Khan Academy for that.